Dimensional analysis really is the most important math skill you can have when you're learning introductory chemistry because it's the foundation for converting units. Now, I have found that a really easy way to learn the process of dimensional analysis is to start with metrics, because metrics is something that we need to understand in science anyway, but also metrics is something that's tangible and understandable for us to learn dimensional analysis. So we're going to get two things covered here. Not only how do we do metrics, how do we deal with metrics, how do we convert in metrics, but also how do we use this thing called dimensional analysis that is so fundamentally important in introductory chemistry. In an earlier video, which the link will pop up, it'll be in the description, I walk you through all the rules, all the steps for solving dimensional analysis. It doesn't change. It never changes. It's these three simple steps. If you're unsure what this means, why don't you go back and check that out? But if you do know, let's move forward. Now, here's the thing. An important piece of dimensional analysis is knowing what conversions you need to be able to cancel the units that you don't want in your final answer. So I use this table right down here. This is the metric conversion table for the simplest metric conversions that come right off of the base unit. If this doesn't look familiar, it's okay, because we're going to work our way through this, because this table gives us the conversions we need in metrics. Now, the table's not complete, but that doesn't matter. Remember, we're using metrics to learn dimensional analysis. So these are going to be our conversions. Now, in my class, it is required that this needs to be memorized. So I'm going to put it up here. Now, if you live somewhere where you already use metrics, this is intuitive to you. But here, where we live in America, metrics is something that really has to be learned. For memorizing this simple chart, I memorize it this way with a mnemonic. King Henry died drinking chocolate milk. That stands for the kilo, the hecto, the deca, the deci, the centi, and the milli. Really what that means is 1 kilo something is equal to 1,000 of the base unit. So let me walk you through this, just some basic ones. This chart, when we're talking about the base unit, could represent length, where the base unit would then become meters. Or if we're doing mass, the base unit would become grams. And we just need to substitute anything in that we want. So let's look. This is the prefix kilo, and now our base unit is grams. So if I was going to change this whole chart, which isn't necessary as long as you can just remember the framework of the chart, we're saying that 1 kilograms, I'm just trying to keep it similar to what I have here, 1 kilogram would be better use of the English language, is equal to 1,000 of the base unit. Well, what is the base unit? We just change it to grams. If we switch to liters and we're trying to do some conversions and we have 1 deciliter, that's equal to 0.1 liters. Now, I know there are 100 or 1,000 different ways you can learn metrics, and that's totally fine. But after 15 years of just teaching how to get students to be able to convert in metrics, this is the most simple form. So stick with me. Again, look, we have the King Henry died drinking chocolate milk. I don't know what that means. It's just a way to remember K, H, D, D, C, go back, D, C, M. I would take some time. I would write this down. We're going to need it. Commit it to memory because you'll use it throughout chemistry, throughout physics, throughout math, anytime you're doing measurements in System International or the metrics unit. So let's talk about what I mean by the conversion factors then. If we have a conversion where we are needing something, a relationship between kilo and grams, like kilograms, then we can look over here and find 1 kilogram, and turn that into grams, or the relationship of the grams. It is equivalent to or equal to 1,000 grams. Notice this is a conversion factor. If you've watched the other video about dimensional analysis, you know we have to be able to write these to cancel units to solve our problems. So we just took and wrote one of them from this chart. Can we keep going? Sure. Let's look at the next one. What about if we need some conversion with grams to kilograms? Well, let's see here. We come over here and we'll look at the relationship. If this base unit has been changed to grams, then this means 1 kilogram is equal to 1,000 grams. Or 1,000 grams has a relationship with 1 kilogram, or 1,000 grams is 1 kilogram. Notice we're able to flip-flop these. Over here we have grams on the bottom. Over here we have kilograms on the bottom. And these are equivalent because they're measurements. There's a relationship between them. So we can flip-flop them. What about centimeters to meters? We come over here and we find the prefix centimeter, and that is equivalent to 0.01 meters. So let's write that out. 1 centimeter is equivalent to or is equal to 0.01 meters. Likewise, 0.01 meters is equivalent to 1 centimeter. Okay, the point is we can build conversion factors out of this conversion table. And you'll find as I'm working through lessons, the best way to learn these is to do examples together. So let's dive in. And we always start off with something very simple and we work our way up and up and up until we get into real world chemistry type problems. So let's start off with something that's manageable and simple. Now, I go back to the rules that we learned before. We write down what we know. Well, let's identify first what we know. How many meters in 2.1 centimeters? Okay, so we have 2.1 centimeters. Now, I know that probably a lot of you could just look at this and say, well, I can tell you right off from my head, like looking, and can just tell you the answer to that. Why are we doing math? Because we're doing math with this because we're using metrics to learn dimensional analysis, using something simple and understandable to learn something that can be quite complex. So number one, I write down what I know, which in this case is 2.1 centimeters. My goal when I get over here is to turn that into meters. Okay, so we just wrote down what we know, and then I included what we're trying to solve for so that we have a goal. We come over here and it says set up conversions to cancel units. Well, if you remember anything from our last lecture together, centimeters right here is not in my final answer. So I've got to get rid of it. How do we get rid of it? We put it on opposite sides of the line because this and this will cancel out. Then I say, okay, what can I turn centimeters into? Could I turn it into meters? Well, in this case, we can. Let's find it over here on our chart. We've got 1 centimeter is equal to 0.01 meters. So I come back, I fill in 1 centimeter is equal to 0.01 meters. Let's cancel a few things. That centimeters and that centimeters cancel. The only units I have left in my problem are meters, and look, that's what I want my answer in. So let me clean things up, and let's put our answer here. Now, I'm going to take you to the calculator. I don't even know if you need the calculator, but again, problems are going to get more and more complex. So as they do, we need to figure out, well, how do we deal with these, right? So we plug this in. We're going to take 2.1 times 0.01. I'm going to hit enter. Now look, we've got to divide by 1, but maybe you're at the point where you understand that anything divided by 1 is itself, so I wouldn't really need to do that step. I'm just doing it to show you, which means we have an answer now. 2.1 centimeters is 0.021 meters. Good, because in my brain I knew that's what it was, but this shows that that process works. So let's step it up. How many kilograms is 3.1 decigrams? This is just a conversion problem. Conversion problems require that we use dimensional analysis. And here are my steps for dimensional analysis. I'm trying to solve for how many kilograms is in 3.1 decigrams. So I write down what I know, which has to have a number with it. In this case, that's going to be 3.1 decigrams. When I get done, I want my answer over here in kilograms. Okay, so now we wrote down what we know and we need to set up conversions to cancel the units. Well, what if I don't know what conversions to use? That's okay, because I don't want decigrams in my answer. See, decigrams here, don't want it there. The only way to get rid of it is to put it down here in a conversion factor to cancel the units. Then I say to myself, what can I turn decigrams into? And then I would put it here. Let's go back to what we have. 1 decigram is equal to 0.1 grams. But I want to go from decigrams into kilograms. The thing is, I don't have a conversion using this table that will allow me to do that. But just think, if I can go back to the base unit, like if I can turn decigrams into grams, ultimately then I could turn grams into kilograms, right? And that's the point of us using metrics to learn this process of dimensional analysis. Sometimes it takes multiple steps to get to our answer. And that's no big deal. That doesn't stress us out because, well, we just 1 decigram is equal to 0.1 grams, is equal to 0.1 grams. Let's cancel some units and see where we're at. Okay, now I have grams left, but I want to be in kilograms. So I need to set up conversions to cancel units. I just keep going. Another conversion factor. That conversion factor has got to have grams on the bottom because, right, that's the only way to get rid of the grams, and I don't want grams over here. Now, can I turn grams into kilograms using my chart of conversions? Well, let's find them. I've got 1 kilo, let's write in grams just to be helpful, is equal to 1,000 grams. So there is a relationship or a direct relationship using this chart where it says 1 kilogram or kilogram, 1 kilogram is equal to 1,000 grams. If we cancel our units because they're on opposite sides, look, the only thing we have left are kilograms on the top. That's what I want my answer in. Let's plug it into the calculator just so we have some practice calculating things. I'm going to take the first part of the problem, which is 3.1. I'm going to times that by 0.1. I'm going to hit enter because I'm not using any parentheses or anything, which means I now have an answer for the first part of that problem. Calculator saves the answer, and I'm going to take that whole thing times 1, but I don't need to times it by 1 because that'd be the same. I'm going to take that whole thing divided by 1,000, divided by 1,000. Enter. Now, let's look. On the calculator here, it says 3.1e negative 4. I can't write that down. I mean, I can, but I never should write that down because that's trying to tell me something. It's trying to tell me scientific notation. And what it means is this. 3.1, the e that you see on the screen means times 10 to the, and then the next number is negative 4. So we don't ever write the e. The e represents this times 10 to the whatever the exponent is. It's literally what it means. The e means exponent or exponential notation. I always leave the units with this, which is kilograms, and I'm going to write this out in decimal mode so that you can see what this looks like. We have a decimal, 1, 2, 3, 3, 1 kilograms. So 0.00031 kilograms. It's the same. These are the same answer over here. This is probably a better answer to include because it's in scientific notation. Now, I'm going to do this other thing one time just to show you. If it doesn't make sense to you how I put that in the calculator, then let's put it in with parentheses because sometimes if we don't use parentheses, we're going to end up with a weird order of operations. We're actually not going to right now because we don't have any we don't have any scientific notation in here, but we're going to when we get into actual chemistry. So let's go back over here and plug it in just to show you that you are welcome to use parentheses, but it's not necessary. We're going to continue to shortcut it just like we did. So 3.1 times parenthesis 0.1 divided by 1 parenthesis times parenthesis, a lot of parentheses. See, if you mess any of this up, it doesn't work. Divided by 1,000 parenthesis. Now it looks like we have it on the screen. Let's hit enter. It's the exact same thing we had before. The other thing I find to be really important as you're learning these concepts, and if you're trying to learn from a video, is to pause the video and try this on your own. In my class, when we do this, I just pause the class. This is up on the board and I say, okay, now it's your turn. And I wander through the class and I see how people are doing and I answer questions. And then after a certain amount of time, and everybody's had some time to struggle or to shine and try to figure things out, we do it up on the board so everybody can check. I tell you that because I'm going to highly encourage you right now to pause, try this on your own, and then come back and check. We have 150 hectoliters, and we're trying to turn that into centiliters. Again, we're trying to use simple things to learn the process of dimensional analysis. First thing I do is write down what I know, which is 150 HL, which is hectoliters. I'm going to put my goal. I don't know how much space I need, right? I don't have a clue. So I'm just leaving some space here because I think this is a nicer way to learn it if you're watching and following along. Notice I have hectoliters. I don't want it in my answer, so what needs to go on the bottom? I can hear you shouting through the computer telling me hectoliters has to go down here to cancel that out because I don't want it in my answer, and it's the only way to get rid of it. So thank you for shouting that through. And then I say, what can I turn hectoliters into? Let's go back to our chart. I find 1 hecto, and now it's liters. That's equal to 1,000 liters because we've just changed the base unit to liters sort of hypothetically here. And so we can turn hectoliters into liters. 1 hectoliter is equal to 100 liters. Let's cancel these. If I stop right now and calculate, my answer would be in liters. But I want my answer in centiliters, which means I'm not done. I just continue to set up conversions until I get to the answer I actually want. Let's set up another conversion. Now you're telling me what has to go down here to get rid of liters? I hope you just said liters. And what can I turn liters into or can I turn liters into centiliters? I can. There's a relationship right here because I see centiliter is equal to 0.01 liters. Okay, so 1 centiliter is equal to 0.01 liters. Canceling. And look, the only units I have left now are centiliters. And centiliters are what I want my answer in. Let's calculate it. We take 150. I'm going to use my shortcut method just to streamline this. So times 100. I'll hit enter. I do not need to divide by 1. The next part says times 1 divided by, I don't need to times it by 1. So let's just divide it by 0.01 and hit enter. If you don't like that method, again, use the parentheses. You'll get to the right answer. Again, just trying to save time. It's 1500000. It is centiliters. If I write it out in scientific notation, I have 1.5 times 10, and you would go from there 1, 2, 3, 4, 5, 6 times 10 to the 6th centiliters. Both of these answers are perfect. I mentioned before in an earlier video that dimensional analysis is really just problem solving your way through converting units using math to do science. And we've got some right here because we've got 65 kilograms. Oh, that's a nice arrow. I'm not sure why, but I'll leave it because that looks fun. And I need to turn that into pounds. So this is new. We've done the metrics, right? But now what happens if we're not just staying within metrics? It's no big deal. Nothing changes about anything we're trying to do here because we still use those 3 simple rules. And if I'm stuck, I just go back to, well, it says write down what you know, which is 65 kilograms. What am I trying to turn that into? In this case, I'm trying to turn it into pounds, LBS. And look, I've given you a new conversion here. So as we try to problem solve our way through it, we'll find, well, when am I supposed to use that? I don't know. But I do know that I don't want kilograms in my answer, which means I have to have what down here? Kilograms, you're correct. And I want to know, can I turn kilograms into pounds? Oh, well, I didn't have that before, but look, I can turn 1 kilogram into pounds because 1 kilogram is about 2.2 pounds. It doesn't say it's exact. This is the English system. This is the metric system. So this poses an interesting problem. First, let's cancel our units. Notice the only thing we have left are pounds. We take 65 times 2.2 and we get 143 pounds. Okay, now I feel like we've taken a step back. We were just doing complex multi-step problems and now you just bring this one out? Let me tell you why. One important thing that we need to be able to do in science are significant digits. Now, I'm bringing up significant digits and I'm bringing it back. And if you don't know what significant digits are, there's links down there in the description, and there'll be some links probably popping up on the screen to go and teach you about significant digits. But the question becomes, should I round this answer? Or if I do, what should I round it to? Well, let me tell you. When we use significant digits, this number right here has two significant digits, 1, 2. This conversion right here has two significant digits. I'm going to walk you through all of this in the next video. So if you're just freaking out right now, you're going to be okay. It's fine. Just bear with me. There's a reason I put this one up there. This has two significant digits. It's a multiplication problem. This conversion factor has two significant digits. So how many significant digits, or how many digits, do I get to have in my answer? 2. 1, 2. So what I've just done here is I have answered this question using dimensional analysis with the correct number of significant figures. Boy, we're making progress. Look at us go. And I hope you're feeling more comfortable with dimensional analysis and using metrics, because there are two goals throughout this lesson. One, to be able to quickly convert metrics, but really using metrics to learn how to do dimensional analysis. We're going to get up to problems that aren't real easy and aren't real understandable, but now if we learn this process using metrics, which are understandable, you're going to be so much better at it when we get there. We've got one more layer that we need to add, and that's that significant digits thing, the one we just briefly talked about on the last slide. It's really taking these two fundamental parts of math that we use for chemistry and combining them together. And that's what's going to happen in the next video. So thanks for watching. There's lots of links on the screen. Come over to bealsscience.com and see me there. Hit the subscribe button. Watch the other videos on Beals Science School. I don't know. I just do all this to remind you to keep on learning.